So today will be the final official lesson on trig. We have one more lesson to actually discuss in this unit. But today will be the last one that we officially do. Trig obviously won't continue to discuss it, but the last official lesson. We talked last time about using some trig functions in order to complete some sorts of word problems. There are some things that actually come up in word problems that are not something we discussed last time, and so I want to discuss those right now so we're all on the same page. And so you can see there that there are two basically vocabulary words that we want to address. The first one is angle of elevation. Obviously, we know that there's angles in our triangles, but the one that they may specify is something called the angle of elevation. It's an angle measured from a horizontal position, so of course, nice flat area, and it's usually from the ground, and it's going upward. Why is it called an angle of elevation? Because your eyes must look up and you should elevate in order to see the top of the object. So if you're trying to, in particular, measure something that's extremely tall, you can't go to the tippy top, drop a ruler down to measure. You would, of course, use this indirect measurement or use your trigonometry to do that. And so sometimes they'll talk about the angle of elevation for that particular area.
Oh, sorry.
Please note that angles of elevation are always located inside the triangle. They are always inside the triangle that you're looking at. So you can see on the picture here, we are trying to measure the height of this tree. So of course the tree is perpendicular to the ground, so that's why we have our 90-degree angle here. Our angle of elevation is right here. So it's this little guy looking up to see the top of the tree.
I was somebody was kicking out here.
Questions?
Wait, I got a question. Why did you put like a little thing next to it?
That's just the theta. So
Oh.
saying, from the theta. Now, you can ask an angle of elevation. They may also reference something called the angle of depression. So this is not a sad angle. Okay. This is another type of way to look at a problem. It's an angle measured from a horizontal position, so it's kind of the same thing, except it's usually
Bam.
downward.
Due to pressure down.
Exactly.
Years.
Now, yes, ma'am? Angles of depression, excuse me. Angles of depression are always located outside the triangle. So you can see here, if I'm a person standing at the top of my lighthouse, I have this arbitrary horizontal line that's going through the sky. My angle of depression is the angle I'm looking down at from that horizontal, so it's on the outside here, not on the inside like we had on the angle of elevation. Now, the good news is, how is this angle of depression related to this angle inside here? Doesn't bisect. That's a good thought. What is this total angle here? It's 90. So we have this. If we know this one, then we can subtract 90 to get the other one. So they're complementary. Okay. So elevation up, depression down. Elevation is inside, depression is outside. Now, the final thing to point out here, if you look at this picture, let's take a look at the various angles. First of all, we have indicated, what is angle 1? Is that an angle of elevation or an angle of depression? Depression. So that's a depression angle right there. What about angle 2? Yeah, so that's the little guy looking up at the bird. I think that's the bird. What about 3? Depression. That's the guy looking down at, I guess, the shore. And number 4 is elevation. Right. Now here's the thing that happens that's kind of nifty. You'll notice, of course, that we have our ground or our C line here that is a nice horizontal line. You notice you have the line where the guy is looking across. That's a nice horizontal line. We have the horizontal line that is where the bird is at. What is true of all 3 of those lines? Parallel. And so what ends up happening, you have this buckling transversal. That's our hypotenuse of our triangle, which means it's what's true of 3 and 4. They're the same. Why? What are they called? Those are alternate interiors. Okay? So angles of elevation and depression are congruent. Because they are, I'm going to write down here since the space is a little small, alternate interior angles. So while you can, of course, subtract from 90 degrees, as we mentioned, that makes a 90-degree angle there at the top, you can also just say, okay, if I know this angle of depression, I also know the angle of elevation down here, so I can use that as my reference angle when I'm trying to find this. So either way, way to handle the problem. All right, so take a look at the problems we have there at the bottom. See if you can identify whether you have angles of elevation or angles of depression in the pictures.
Oh. So you just label it? You just label it?
Yep, you can just label it to your E like we did those ones there. Ladies, can we mind our own business and work on our paper?
Yes, please. So what did I read? Wait, would that be the question stuff?
Talking about your guy standing in the boat, and you're looking over there, and you're looking down, you're up. Okay.
You watch it again.
No.
Oh, that's
I feel better.
Put it back there. Ooh. We go to the top. You feel better.
Better.
Yeah. What you said? Do you go call your mom? She said no.
He left it. We are going to finish this lesson. If that means we're going to be here an extra 5 minutes, we will. So stop wasting my time so we can get through this. And it's only a few of you, but it's unfortunate. All right, so number 1, elevation and pressure.
Deflation.
Elevation, you're definitely.
I knew I was right now, sat there and second guess.
What about number 2? Pressure and pressure. Look down out of the boat. About 3, elevation. And 4, hold on.
Wait, hold on. How is angle 1 elevation?
Because the guy is looking from the submarine up to the boat.
Wait, so you just so you basically just look at the line, like the little this right here, and then you say picture a man standing in there. You just See what they're looking at. So,
I always second guess myself and get it wrong.
Alright, so now let's take a look over here. I think they're in the rainforest or something. 5, what's that? Elevation. Because the guy is looking up at the waterfall. How about 6? Another person looking up at the waterfall. 7? And 8. And keep in mind, the reason that there's 8, which is a combination of the 2, if you look at the triangles, 6 is this whole 8. That's the over 6. That's the depression of that one. Versus 5, it's a much tighter angle there, which of course goes with the 7 that's there. So it's just a matter of different transversals. Questions? Alright, so let's look at a sample problem, what this might look like, what we have to solve for. So, if your distance from the foot of a fire tower is 20 meters and the angle of elevation is 40 degrees, find the height of the fire tower. Always start with pictures. Pictures are pretty. Well, some pictures are pretty, my pictures aren't so pretty, but whatever. So we have a fire tower. You know, like a forest or something like that. They have towers to check to make sure to see how fire is progression. We know that we are 20 meters from the foot of the tower, so we are 20 meters. And we have an angle of elevation, so which way is that going? Boom. And that angle of elevation is 40. They want us to find the height of the tower. So we have our tower, we want the height.
wait. So the 40.
Alright, so any questions about picture? So we now label our parts. Where's our hypotenuse?
Over the elevation.
Here. So we don't have anything over there. Where is our opposite?
Across where the X.
Okay. And so then we of course have our adjacent down here. So we're going to use the tangent because that's our TOA. So the tangent of 40 degrees is opposite over adjacent.
So then we get rid of this 40.
So we multiply by 20.
So it's going to be 20 tangent 40.
Yep. Okay, 20. Right.
Yeah.
I don't see
No,
anybody
you
on
multiply. So that's 2.
16.8.
620. You get 620? That's 620?
Hold on.
620?
Wait, no, don't do it yet. Don't do it yet.
I got 6.
Hold on. That's what I got. I got
Somebody told me 60. I got 16. 16?
Wait. I'm getting it wrong.
I'm getting it wrong too.
Is y'all thinking degree mode?
Are you in degree mode?
You probably say 60.
Oh, no, my thing was in
I
degree.
said no.
Questions?
No, don't go yet. I got it wrong. Oh, okay, I got it now. So this is how you do it.
Now, this one conveniently gave us a picture so we don't have to work as hard. Since the angle of depression from the top of the castle to the boat is 25 degrees. Where does that 25 degrees go?
To the point
So right up here is our 25 degrees. Why are we talking? The boat is 50 meters from the base of the bluff. Where does 50 go?
At the bottom.
How high are the bluffs to the nearest meter?
So,
Figure it out. That's there.
so
I think
basically,
what they really want is how high are the bluffs and the castle. That's what that word is. Yes.
so basically you're going to say that you get for the top one.
Yeah. Did we mark that angle of depression correctly? Not quite, because if you put the angle of depression on the outside. No, we put it on the inside. So we have plugged up a little bit. Y'all disagree. 25 is right here. Remember, it's with the horizontal. The difference is that isn't 25. This guy's 25. Remember the alternate interior thing we talked about?
So the inside of that is
90 minus 25.
so we need 65.
So we can use 65 there, or we can just put 25 down here at the bottom. Either way. Okay. So the important message here is that when you have angles of depression, don't stick them inside. They go on the outside. Okay? Let's take a look at another one real quick where we have that same kind of thing happening. Let's take a look at number 5 there that you tried. We have a lighthouse operator. We have the lighthouse. He is 25 meters above sea level. Sees a sailboat at point S, so we got a boat over here. The angle of depression of the sighting is 10 degrees. So as the guy is looking down, it is 10 degrees in here with the horizontal. Not on the inside, it's on the outside. Depressions are on the outside. Right? Of course, we need to figure out how far away the boat is from the lighthouse. We're missing that piece down here. What do we do with this 10 degrees? We can do one of two things. We can say 90 minus 10 gives us 80 in here. Or we can say alternate interior angles. We have 10 degrees on the outside up here. It means we have 10 degrees on the inside down here. So, okay? Angles of elevation are a little easier than angles of depression, but the depressions are all stupid outside. I don't have the answers in front of me. But for this one, what did you do?
I put in my calculator 25
that should be okay.
She gave us the tissue. She said we were our spotlight, so we didn't go get a time tag. Y'all what? We didn't go get a time tag because I was late. I was in the gym.
What are you doing?
Babe, can you take my calculator out?
Page, it looks like a
Get her now.
So what does that mean?
Somebody needs to get her. Somebody needs to get her. Somebody needs to get her.
Zip it. Put it in your back pocket.
Put it in your what? Your what pocket? You're not going anywhere. It's all the calculators and everybody sit. Your what pocket?
Damn pocket. Hello, damn.
I can't hear you. Alright, everybody has the trick word problem worksheet? That is homework. Of course, hard. It's done. And that's all that quiz.